This is lesson 8-2, Geometric Figures, and it starts on page 438. This is example 1 on page 438, and it says a school's landscaping club is designing a 4-sided patio and garden. The patio has 2 perpendicular sides that each measure 4 yards, and a third side that is perpendicular to one of the equal sides but is twice as long. One angle of the patio measures 135 degrees. Make a scale drawing of the patio using a scale of 1 centimeter to 1 yard. All right, so a 4-sided patio, that gives me some options. A 4-sided patio could be let me change that to a pen. It could be a square, it could be a rectangle, it could be a parallelogram, it could be a trapezoid, it could be a rhombus, it could be a kite. So I was just sort of brainstorming all of the 4-sided figures. And I know there are 2 perpendicular sides. So perpendicular means that they're going to make right angles. So I think that eliminates some of our options. So no right angles, no right angles, no right angles. And if I have 2 perpendicular sides that are 4 yards, that means that 2 of the sides have to be the same length. And the other side is twice as long. So that eliminates a square. So that leaves me with a couple of options. I could have a rectangle and I could have a trapezoid. But this right here, 135 degrees, tells me I can't have a rectangle because a rectangle has all 90-degree angles. So I feel like we're looking at a trapezoid here. So we've already gone ahead and started to draw this. We have 3 of the sides. I've got this side perpendicular to this side. This is twice as long, so I've already got the twice as long. I've got the third side perpendicular. I've got one of the sides is 4. This one, if you look, is also 4, so I've actually got both sides that are 4. I'm about to make 4 sides. I'm going to put the last one in. All I'm missing is 135 degrees. So I don't have a protractor with me on this screen, so let me think about 135 degrees. 135 degrees, I know what a 90-degree angle looks like. It looks like a corner. And that leaves a 45, which would be half of a corner more. So I'm looking at this and I think if we just connect these 2, this angle right here is about 1.5 corners. We have 1, 2, 3, 4 sides. 2 of them are 4 centimeters. One of them is twice as long. I think we've got it. All right, this is the try it at the bottom of page 438. It says use a ruler and a protractor to draw a quadrilateral. So I know I have 4 sides again. 2 equal sides that meet at a right angle and 2 non-adjacent sides of the same measure. Okay, so we've got some vocabulary here. We know a quadrilateral gives us some options. It has 4 sides, so it could be I keep forgetting to change that to a pen, sorry. So I know it could be a square, I know it could be a rectangle, it could be a parallelogram. A quadrilateral could also be a rhombus, a trapezoid, or a kite. All right, so that's the quadrilateral. We have two equal sides that make a right angle. Well, parallelograms don't have right angles. A rhombus doesn't have a right angle. A non-adjacent. Okay, non-adjacent means they're not next to each other. So non-adjacent, not next to each other. Okay, let's see what we can do here. I'm not going to use a ruler or a protractor. We're just going to eyeball this and kind of get a good sketch for us. So let's go ahead and start with the right angle, because right angles are easy for me. And I know it's made up of two equal sides. So I'm going to draw a right angle. That's a nice corner. I'm going to say this side and that side are the same length. So I've taken care of the right angle, two equal sides. And then the non-adjacent angles, two non-adjacent angles, they are not next to each other, but have the same measure. So I feel like we could just go like this. So this angle and this angle are not next to each other. So I have two non-adjacent angles, but they look like they're about the same size. And I have 1, 2, 3, 4 sides. I think I've got it. This shape right here, that's a kite. This is the example number 2 on page 439. Mr. Miller's classroom has desks shaped like equilateral triangles. He is planning to arrange the desks for a lunch for 10 people. If one person can sit at the edge of each desk, make a sketch to show how many desks he needs. So here we have Mr. Miller's first option. They're kind of in a linear pattern. They're kind of lined up side by side. And you're going to notice the circles are people. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 people, which is what we need. And we want to know how many desks he needs. So if he does this option, he's going to need 8 desks. But wait, Mr. Miller has other options. So he has this option where it kind of looks like maybe flowers. And the circles are people. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 people. But in this case, he needs 14 desks. There's going to be more than one answer. In fact, there's another answer we're going to talk about in a minute. All right, this is example number 3 on page 439. And we're not going to use technology for this. So we're not going to use any kind of drawing software because we just don't have that available. But let's see if we can figure it out just sketching it. An engineer makes a scale drawing of the floor of a building. The floor has two pairs of parallel sides that are 50 feet and 80 feet. So 2 pairs of parallel sides. 2 of the 4 angles measure 60. And we want to figure out what shape that is. Okay. So it looks like we might have 4 sides again. So if we have 4 sides, remember we can make a square, we can make a rectangle, we can make a parallelogram, we can make a rhombus, we can make a kite, we can make a trapezoid. All right, so let's eliminate what it cannot be. So 2 of the 4 angles measure 60. Well, that takes out the square because all its angles are 90. Takes out a rectangle, all its sides are 90. We have 2 pairs of parallel sides. Parallel means they're like railroad tracks. So that takes out the trapezoid and it takes out the kite, because those, well, the trapezoid has 1 pair of parallel sides and the kite could technically have none. All right, so I'm down to 2 options. But I know that the sides are different. One is 50, or 1 pair is 50 and 1 pair is 80. That takes out our rhombus, which I guess leaves us with our parallelogram. So a parallelogram would look something like this. I would have 50 feet, 50 feet, 80 feet, 80 feet. I have 2 pairs of parallel sides. 2 are 50, 2 are 80. And I've got a 60-degree angle right there and a 60-degree angle right there. I believe we have the right answer. This is the try it on the bottom of page 439. And we're only going to do A because if you remember, we are not using geometry software. Okay. So let's go ahead and make a sketch of another way Mr. Miller can arrange the desk to seat 10 people for lunch. I'm going to let you try this. So there were 2 options in example number 2. Let's see if you can come up with another way for him to seat 10 people and then tell me how many desks that would take. Go ahead and pause me while you do that and then come back and check out some of my options. All right, just quickly, I came up with a couple of different ones for us. So here I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 people with 1, 2, 3, 4 desks. Here I have another one. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 people with 6 desks. Now this is by no means all of the options, so you may also have a good one that works.